good morning, good afternoon, or good whatever time it is. ArXiv just dropped 561 new AI papers today, and we found 119 that stood out to us. And hopefully you'll find them interesting too. Don't let the numbers scare you. You can drop off anytime. Hop in, check out a few, and stay as long as you like. Let's get started.
Researchers at Stanford University developed a new way to measure how confident language models are. Instead of asking for a direct score, they compare the model's confidence across different questions. This method improved confidence scores by an average of 3.5%. Researchers at Tsinghua University studied physics-informed neural networks, PINNs. They found that PINNs sometimes fail because of low gradient correlation between points. Their new PINN architecture solves this, improving performance by 46% compared to other advanced models. Researchers at Stanford and MIT, along with a team from Transluce and UC Berkeley, developed a new way to find problems in language models. They trained investigator AI agents to create prompts that trigger specific behaviors, like hallucinations or harmful responses. Their method achieved a 100% success rate on some harmful behavior tests and an 85% hallucination rate. Researchers at Yale University and the University of Pennsylvania, along with colleagues from City University of Hong Kong, developed a new method called SOAP to improve physics-informed neural networks, PINNs. SOAP uses second-order optimization to align conflicting gradients, achieving 2 to 10x better accuracy on 10 challenging PDE benchmarks, including turbulent flows with Reynolds numbers up to 10,000. Researchers at Carnegie Mellon University developed regularized Langevin dynamics, RLD, for combinatorial optimization. RLD regularizes the expected distance between solutions, improving exploration. Their new simulated annealing algorithm, RLSA, is 80% faster than the previous best. Researchers at the University of Washington and the Allen Institute for AI, along with colleagues from Stanford University, created Zebra Logic. It's a new benchmark using 1,000 logic puzzles to test LLMs. Even the biggest models struggle with complex puzzles, showing only around 30% accuracy. The study uses search space size and Z3 conflict counts to measure puzzle difficulty. Researchers at MIT found that 3 large language models, LLMs, use a surprising method for addition. They represent numbers as a generalized helix and use a clock algorithm to compute sums. One model, GPTJ, achieved 80.5% accuracy on 10,000 addition problems. Researchers at Stanford and Microsoft, along with colleagues from Georgia Tech, developed COLLABLLM. It's a new LLM training method using simulated conversations to improve long-term interaction. Results show an 18.5% increase in task performance and 46.3% better interactivity. Researchers at Amazon Web Services and the University of Illinois Chicago, along with other teams, created COD-LLM, a 12 billion parameter LLM. It's trained on a new dataset with over 1 billion tokens to better understand data management. COD-LLM outperforms GPT-4o by 12.1% on a table selection task. Researchers at NVIDIA developed Reward-Aware Preference Optimization, RPO, a new framework unifying many large language model LLM alignment algorithms. Using 120,000 prompts, they systematically studied design choices, offering insights into improving LLM alignment. Researchers at Cisco Systems found that current LLM cybersecurity evaluations don't fully capture real-world risks. Their study shows that while LLMs are often willing to help with malicious tasks, 90% compliance, they're only accurate about half the time, 50%. This highlights the need for a more comprehensive risk assessment framework. Researchers at Tsinghua University and ByteDance created a new speech-to-speech translation model. It uses 300 hours of paired movie audio, English and Spanish, to translate while keeping the emotion in the voice. The model uses discrete units, avoiding text as an intermediary. Researchers at Tsinghua University and TikTok, along with colleagues at other institutions, improved cascaded speech-to-text translation. Instead of using only the best initial speech recognition result, they used multiple results and self-supervised speech features. This boosted translation accuracy, with only 45.35% of top-ranked candidates giving the best translation. Researchers at Simon Fraser University and the University of British Columbia, along with colleagues from other institutions, developed radiant foam. It's a new 3D scene representation for real-time differentiable ray tracing. Unlike methods using rasterization, it uses a volumetric mesh and achieves over 300 FPS in some tests, more than twice as fast as existing methods. Researchers at Carnegie Mellon University introduce a new framework for teaching AI inductive generalization. They define a series of progressively harder problems, using Peano's axioms to formalize the difficulty progression. This differs from previous work, which typically uses a simpler in-domain/out-of-domain split. Researchers at Princeton University found that using one top-performing large language model, LLM, repeatedly, self-MoA, often beats mixing many different LLMs. Self-MoA showed a 6.6% improvement on Alpaca Eval 2.0 and a 3.8% average improvement across other benchmarks. Researchers at École de Technologie Supérieure and Mass General Brigham, along with other institutions, developed a new method for MRI quality control. They trained a model on synthetic motion data, then used transfer learning for real-world QC. The transfer learning model achieved a median balanced accuracy of 0.41, outperforming a model trained from scratch, 0.35, and using far fewer resources. Researchers at Tsinghua University and Beijing University of Posts and Telecommunications, along with colleagues from other institutions, present Unia Tan. This new method unifies softmax activations in LLMs to reduce inference costs. Experiments show comparable performance with significantly lower latency. Researchers at Google Cloud AI Research and Google DeepMind, along with colleagues from the University of Cambridge, explored many-shot in context learning, ICL, in LLMs. They found that simply adding more examples isn't always best. Their new bridge algorithm iteratively selects the most influential examples and uses them to generate even better ones. On some tasks, using only the top 10 examples matched the performance of using all 42. Researchers at Microsoft and the University of Virginia, along with other institutions, analyzed large multimodal model LMM serving. They found cross-attention models are 10x faster than decoder-only models for prefill. Their new decoupled architecture improves efficiency by independently scaling different LMM stages. Researchers at Beijing University of Posts and Telecommunications and Beijing Jiaotong University, along with other teams, developed PMMOE. This new personalized federated learning method shares converged private model parameters, improving accuracy by up to 48.64% compared to Fed-AVG. It uses a mixture of experts to weigh and filter these parameters. Researchers at Carnegie Mellon University and Microsoft Research studied LLMs as decision-making agents. They found LLMs excel at exploring large action spaces, but struggle with exploitation, even with helpful hints. Even with improvements, LLMs performed worse than simple linear regression in some contextual bandit tasks. Researchers at RWTH-Aachen University and the University of Pennsylvania, along with a team from 3 other universities, developed PARA, a new parameter-efficient fine-tuning method for LLMs. PARA uses a lightweight vector generator to adjust hidden states based on prompts, improving performance over LoRa while maintaining efficiency in multi-tenant settings. PARA outperformed LoRa and AdaLoRa on 5 benchmarks with similar parameter counts, around 8.9 m. Researchers at MIT developed a new gradient descent method for KSVD. It uses a simple adaptive step size rule and achieves global linear convergence without needing special information. The method matches the power method's efficiency, needing only O log 1 epsilon iterations for epsilon accuracy. Researchers at Microsoft and Providence Genomics developed UNIMEDABSTRACTOR a zero-shot framework using LLMs for medical data abstraction. Unlike traditional methods, UMA scales to new attributes without needing extra training data. In one test, it outperformed a supervised model by 20 accuracy points. Researchers at Tsinghua University and Beijing Institute of Technology, along with colleagues from Beihang University, developed TROI, a new method for decoding brain activity from fMRI scans. It uses a data-driven approach to select only 3,000 important voxels, improving accuracy compared to using all voxels. This is especially helpful when data from new subjects is limited. Researchers at Carnegie Mellon University developed a new fair share pricing framework for large language model (LLM) training data. This framework uses data valuation methods to set prices. Unlike previous work, simulations show that unfair pricing leads to a rapid collapse in data transactions after only 100 time steps. Researchers at Oxford and OpenAI, along with other teams, created Agent Breeder. It's a new system that explores the safety of multiple AI agents working together. Unlike past research, Agent Breeder uses evolution to find both safer and more vulnerable agent designs. One red team design scored 81.6% on an inverted safety test in only 10 generations. Researchers at Xi'an Jiaotong University and Peking University developed a new deep learning quantization method. Double rounding achieves nearly lossless bit switching, improving ResNet 18 accuracy by up to 2.7% compared to existing methods. It uses a clever trick of applying rounding twice and an adaptive learning rate scaling technique. Researchers at the University of Toronto and the Vector Institute found that large language models, LLMs, use a catch, tag, and release mechanism. This involves attention sinks and outlier features, explained by low-rank structures in attention weight matrices. Removing these low-rank components eliminates the mechanism. Researchers at Rensselaer Polytechnic Institute and IBM Research developed sparse gradient compression, SGC, for fine-tuning LLMs. SGC compresses optimizer states independently of model size, unlike low-ray. One variant reduced optimizer states by 10x, 896 vs 16,384, maintaining accuracy. Researchers at Stanford University developed a new three-branch framework for ethical AI. Unlike RLHF, this system uses independent modules for knowledge, ethics, DIKE, and adversarial testing, IRIS. DIKE's self-supervised learning on a large dataset improved behavior classification accuracy by 11.3 percentage points compared to a zero-shot approach. Researchers at CUNY at Buffalo and Princeton University developed a new AI model for mapping networks. It uses multiple types of data, multimodal, to improve accuracy. In one test, it was 37.1% better than a standard model. Researchers at Harvard University and Georgia Tech developed Soft Diffusion Actor Critic, SDAC, a new online reinforcement learning algorithm. Unlike previous methods, SDAC uses diffusion models efficiently, achieving over 120% improvement on complex tasks compared to SAC. Researchers at Tsinghua University and Harbin Institute of Technology, along with colleagues from other institutions, developed WASP. WASP generates differentially private synthetic data using multiple language models. It improves accuracy, especially with limited data, e.g., 89.65% on IMDb with only 100 real samples. The key is using a weighted voting system and contrastive learning. Researchers at Stanford University and Georgia Institute of Technology, along with colleagues from several other institutions, developed new high-order numerical solvers for discrete diffusion models. These improve inference speed and accuracy compared to existing methods like tau leaping, achieving second-order convergence in KL divergence. Researchers at Carnegie Mellon University and Bocconi University, along with colleagues from Politecnico di Milano, improved online learning algorithms for Stackelberg games. They achieved EO t-squared regret under bandit feedback, better than the previous EO t-squared/cubed. The key is a reduction to linear contextual bandits in the utility space. Researchers at Stanford University developed a self-playing theorem prover for LLMs. Unlike previous methods, it generates its own training data, doubling the success rate on the Lean workbook dataset to 26.3%. This innovative approach uses a conjecturer and prover to continuously improve performance. Researchers at the Alan Turing Institute and University of Cambridge, along with colleagues from MIT and IBM Research, developed the first exact solution for reverse KL regularized RLHF using multiple reference models. This improves upon previous approximations and achieves O(1n) sample complexity for the suboptimality gap. Researchers at EPFL and Harvard University studied deep attention networks. They mapped these networks to sequence multi-index models, SMI. This lets them analyze the full multi-layer structure. Unlike previous work, in a two-layer model, they found that layers are learned sequentially, with different sample complexity thresholds. Alpha approximately equals 0.14, alpha approximately equals 0.79. Researchers at the University of Texas at Dallas and Tsinghua University along with other institutions, found that current audiovisual segmentation models often ignore audio cues. Their new benchmark, AVS Bench Robust, uses 4,932 single-source and 424 multi-source videos with varied audio conditions to expose this bias. A new training method improves robustness. Researchers at the University of Toronto and Stanford University developed FragmentNet. It's a new model for predicting molecular properties. Unlike older methods, it uses a learned tokenizer to break molecules into fragments, improving accuracy. Trained on a MacBook Pro, it rivals larger models trained on much more data. Researchers at the University of Science and Technology of China and Carnegie Mellon University developed Data Influence-Oriented Tree Search, DIIS. DITS uses influence scores, not just Q values, to select training data for large language model, LLM-based multi-agent systems. This boosts performance by 2.1% to 2.5% compared to existing methods. Researchers at Peking University and Carnegie Mellon University developed cat pruning, a new way to speed up text-to-image diffusion models. It prunes less important parts of the model, achieving a 50 to 60% reduction in computation while keeping image quality the same. Researchers at Tsinghua University and Shanghai Jiaotong University, along with others, developed a faster image translation method using diffusion models. Instead of processing at every step, their diffusion model translator, DMT, works at a single, optimized step, making it 40 to 80 times faster than existing methods. Researchers at Stanford and MIT, along with colleagues from Munich and PINN, developed PERL, a new framework for learning positional encodings in graphs using GNNs. Unlike previous methods, PERL achieves comparable performance to ON-cubed methods with oxygen mononitride or ON-squared complexity. A huge speed-up! Researchers at the Chinese University of Hong Kong and Microsoft Research Asia, along with a team from the University of Illinois Urbana-Champaign, created LLM NodeBed. This new testbed compares 8 LLM-based node classification algorithms across 10 datasets, including new e-commerce data. Over 2,200 models were trained and evaluated to find the best settings for each algorithm. Researchers at Nankai University and Tsinghua University developed error-quantified conformal inference, ECI, for time series prediction. Unlike previous methods, ECI uses continuous error feedback, not just binary, leading to tighter prediction sets while maintaining coverage. Experiments showed consistently shorter prediction sets across various datasets. Researchers at Massachusetts General Hospital and Yonsei University developed a new AI model called DMOE for medical image segmentation. Unlike other methods, DMOE directly incorporates data distribution information into its architecture, improving fairness across different patient subgroups. The model achieved state-of-the-art results on multiple datasets. Researchers at Tsinghua University and the University of Science and Technology of China, along with a team from several other institutions, developed OneForecast. It's a new weather forecasting system using graph neural networks. OneForecast improves 4-day forecast RMSE by 20.66% compared to other models. It uses a neural nested grid method to combine global and regional data for better accuracy. Researchers at Middle Tennessee State University and the University of Texas at Austin, along with a team from several other universities, improved one-step shortcut diffusion models. They added acceleration and jerk to the model, resulting in better accuracy, especially in complex areas. On an 8-mode Gaussian dataset, their HOMO model achieved a Euclidean distance loss of 0.778 compared to 2.759 for the previous method. Researchers at ETH Zurich developed CIMAN, a new framework for legged robots to manipulate heavy objects. Unlike other methods, Cayman uses a novel intrinsic reward based on causal action influence, CAI, and achieves a 96% success rate in complex scenarios with multiple obstacles, using only sparse rewards. Researchers at Peking University and Beijing Institute of Technology, along with other teams, created a new benchmark, PBP, for AI planning. It tests how well AI learns your preferences from just a few examples. PBP includes 5,000 test points and 290 unique preferences across different tasks. Researchers at Tsinghua University developed Sundial, a family of time series foundation models. Unlike others, Sundial uses a new time flow loss and processes continuous data without discrete tokenization. It was trained on a dataset with 1 trillion time points. Researchers at Boston Children's Hospital and Harvard Medical School developed FET-DTIA-Line, a deep learning method for fetal brain (DMRI) registration. It outperforms existing methods on a dataset of 60 white matter tracts across gestational ages 23 to 36 weeks. The method uses a dual encoder architecture and iterative inference to handle low-quality fetal images. Researchers at Stanford University and UC San Diego developed ProvicNet, a new AI model for prostate cancer detection. It uses a foundation model and outperformed radiologists in a study. AUROC 0.907 vs 0.805. The model also improved PSA test specificity from 15% to 38%. Researchers at Stanford University and the University of Miami, along with colleagues from other institutions, developed a multimodal AI model for prostate cancer detection. This model uses both MRI and TRUS images, outperforming models using only one type of image, and even radiologists in some metrics, achieving 80% sensitivity. Researchers at Harvard College and Harvard SEAS developed a new theory explaining critical windows in LLMs and diffusion models. Unlike previous work, this theory makes no distributional assumptions and applies to both model types, improving existing bounds. Critical windows in LLMs were found to reduce accuracy by up to 73%. Researchers at Stanford University and the University of Miami, along with other institutions, developed a new method for detecting prostate cancer in ultrasound images. It uses MRI and ultrasound data, aligning them first to improve accuracy. On 1747 patients, it achieved a 0.212 Dice coefficient, better than previous methods. Researchers at the University at Buffalo and Carnegie Mellon University created VLNav, a real-time vision-language navigation system for robots. Unlike previous methods, VLNav uses pixel-wise vision language features and heuristic cues, achieving an 86.3% success rate, a 44.15% improvement. It runs at 30 Hz on a low-power Jetson Orin NX. Researchers at Tsinghua University and Microsoft, along with a team from Yale and UC, developed SPHNet. This neural network uses adaptive sparsity to speed up Hamiltonian matrix prediction. It's up to 7x faster than other methods, with minimal accuracy loss. Researchers at Meta and the University of Oxford created Branch Train Stitch, BTS, a new way to combine expert LLMs. BTS adds lightweight stitch layers, training only 264 million parameters to merge pre-trained models. This outperforms other methods while keeping the experts intact. Researchers at Carnegie Mellon University and NVIDIA developed ASAP, a new framework for controlling humanoid robots. ASAP uses a delta action model trained on real-world data to fix the physics mismatch between simulations and reality. This led to a 52.7% reduction in motion tracking errors during sim-to-real tests, enabling agile movements like jumps and kicks. Researchers at PINN RIST and Tsinghua University, along with colleagues from other institutions, created Sagali, a new 100-hour open-source speech dataset for the Oromo language. This is much larger than previous datasets, which were smaller and not publicly available. The dataset includes recordings from 283 speakers. Researchers at Wyoming Seminary and the Simons Institute, along with colleagues from Sun Yat-sen University and others, developed video latent flow matching, VLFM. Unlike previous methods, VLFM models the flow of latent patches using pre-trained image models and the HipPO framework. This approach offers theoretical advantages in approximation error and timescale robustness, and was trained on 7 large video datasets. Researchers at the Technical University of Munich and Tsinghua University developed new ways to predict compliance violations. Unlike older methods giving only a yes/no answer, these methods also measure how big the violations are. They tested their methods on real-world data, including one dataset with a 94% activity violation rate. Researchers at the University of Tokyo explored why atom beats SGD in transformer models. They found that uneven gradient norms, gradient heterogeneity, across parameters are to blame, not just noise. Roberta showed much higher heterogeneity than VI-T or ResNet 18. Researchers at KU Leuven and Zhongguan Kun Laboratory, along with colleagues from Hefei University of Technology, developed CCM+, a new module for web traffic prediction. Unlike previous methods, CCM Plus uses causal relationships between services. On one dataset, it improved MSE by 16.5% and MAE by 13.5%. Researchers at IBM and Case Western Reserve University, along with a team from other institutions, used a language model to predict how well antibodies fight influenza. Their model achieved an AUROC of over 0.9 for known and 0.9 for unseen flu strains, using only antibody sequences. Predicting activity for novel antibodies was more challenging, reaching an AUROC of 0.73. Researchers at the University of Pennsylvania developed supervised quadratic feature analysis, SQFA. This new method improves quadratic classification by using information geometry to find the best linear features. On the MNIST dataset, SQFA trained much faster than other methods while getting similar accuracy. Researchers at the University of Toronto developed HAM-NAV, a new robot navigation system. It uses vision language models to understand hand-drawn maps, even with errors. In tests, it achieved an 80% success rate in simulated environments. Researchers at UC Berkeley and Lawrence Berkeley National Lab present ReBlock, a new algorithm for solving huge linear least squares problems. Unlike previous methods, ReBlock avoids expensive preprocessing. It uses blocks of rows, k equals 10 to the power of 3, to solve problems with millions of variables, n equals 10 to the power of 6, and billions of equations, m equals 10 to the power of 9. ReBlock incorporates regularization for better stability. Researchers at Tsinghua University developed autoregressive soft Q learning, ARSQ, for robot controls. Unlike other methods, ARSQ models Q values autoregressively, improving performance by 1.62x on D4RL with suboptimal data. Researchers at Harvard University developed Generative Predictive Control, GPC, for robots. GPC uses a world model trained with both expert and random data to improve action selection. In simulations, GPC boosted performance by up to 40%. Researchers at MIT and NTU, along with colleagues from other institutions, studied how well AI can judge economics papers. They used a large language model, LLM, to evaluate 9,030 papers, finding that while the AI was good at judging quality, it showed biases favoring certain authors and institutions. Researchers at Carnegie Mellon University and Delft University of Technology developed latent safety filters for robots. This new method uses generative world models to handle complex safety issues like spills, going beyond simple collision avoidance. In tests, it reduced safety failures by 63.6%. Researchers at Tsinghua University developed a new method for AI-powered medical image analysis. Their ASAP framework uses a smart data selection strategy to improve the accuracy of medical image segmentation with limited data. It achieved up to a 24.39% improvement in DICE score compared to other methods. Researchers at Oxford and UNIST created a new portfolio optimization model. It uses large language models, LLMs, and decision-focused learning. Unlike other models, it directly integrates prediction and optimization. On the S&P 100, it got 43.53% annualized returns. Researchers at the University of Tokyo developed a new weekly supervised learning framework for neurosymbolic math problem solving. Unlike previous methods, it learns optimal formulas using only problem inputs and answers, achieving a 99.9% success rate on a subset of the mathematics dataset. Researchers at ETH Zurich and the University of Cambridge found a way to trick audio language models. They created audio jailbreaks, sounds that make the models generate toxic text. These jailbreaks work on different audio and text prompts, unlike previous attacks. They achieved a 65% success rate on a specific task. Researchers at Brown University and Harvard University, along with scientists from several other institutions, developed new methods to explain how large vision models work. They used concepts in dictionary learning to identify what features models use, not just where they look. A large-scale human study, 1,150 participants, tested the usefulness of these methods. Researchers at Tsinghua University developed Meta Open FOAM 2.0, an LLM-driven system automating CFD simulations and post-processing. It uses multiple chain-of-thought steps, achieving an 86.9% pass rate and a 6.37 executability score, a huge improvement over the previous version. The cost per case is just 15 cents. Researchers at Florida State University and Imperial College London, along with a team from other institutions, studied the generalization of stochastic gradient descent with momentum, SGDM, under heavy-tailed noise. They found that for quadratic loss functions, SGDM performs worse than SGD, a surprising result. Their analysis uses a continuous time limit and provides a novel, discretization error-bound. Researchers at Carnegie Mellon University and Texas A&M University, along with a team from Amazon, developed CUSP, a new graph neural network. CUSP combines spectral filtering with curvature information, improving performance by up to 5.3% on node classification and link prediction tasks across 8 datasets. Researchers at Illinois Institute of Technology and Peking University, along with a team from 2 other universities, developed Self-Prompt-SAM. This new method automatically generates prompts for the Segment Anything model, SAM, improving medical image segmentation. It outperforms NNUNet by up to 2.3% on benchmark datasets. Researchers at Zhejiang University and the University of New South Wales, along with others, studied II conference fairness. They showed that current submission limits unfairly impact early career researchers. Their new system, using linear programming, aims to improve fairness in desk rejections. Researchers at the University of Basel and UNIEV, Artois, along with a team from 4 other universities, developed a new framework for classical planning. Instead of just finding one plan, they count all possible plans, up to a sextillion, and reason about the entire plan space. This includes probabilistic reasoning and a novel concept called facets for more efficient analysis. Researchers at NYU and Cambridge University improved physics-informed neural operators, PINNs. They used evolutionary representatives of point symmetries, a type of generalized symmetry, for loss augmentation. This improved data efficiency, reducing L2 loss in Darcy flow experiments by up to 0.02. Researchers at Aston University and the University of Toronto, along with a team from 7 other institutions, created a huge new dataset, 132 people from 19 countries, using a wearable device with laser Doppler flowmetry, LDF, and fluorescence spectroscopy, FS, sensors to predict mental health issues like stress, anxiety, and depression. Light GBM was the best model, achieving a ROCAUC of 0.7168. Researchers at the University of Sydney and the University of Chicago studied audio-based attacks on multimodal LLMs. Their new flanking attack uses voice prompts to bypass safety filters. It achieved an 81% success rate across 7 forbidden scenarios. Researchers at Georgia Tech and Adobe Research studied how the source of guidance, AI, expert, group, affects data analysis. In a study with 87 participants, they found AI guidance led to higher perceived benefits, but also more regret. The from whom aspect of guidance was uniquely investigated, controlling for guidance quality. Researchers at Stanford and Emory universities developed a new method for causal inference under network interference. Their distribution-preserving network bootstrap method uses temporal data and generates multiple subpopulations for better estimation and validation. They also created a benchmark toolbox with 6 diverse experiments. Researchers at Peking University and Tsinghua University, along with a team from several other institutions, developed a new recursive likelihood ratio, RLR, optimizer for fine-tuning diffusion models. Unlike existing methods, RLR combines RL and BP, reducing variance and bias. Training Stable Diffusion 1.4 with 50 steps needs approximately 1 terabyte RAM. RLR helps manage this. Researchers at UCLA developed a new method for solving inverse problems. They use difference of convex functions as regularizers. This allows for strong convergence guarantees, unlike many other neural network-based approaches. Their method outperforms existing techniques in CT reconstruction tasks, achieving better PSNR and SSIM scores. Researchers at the University of Oxford and the Czech Academy of Sciences, along with other institutions, developed Reducer, a new system for inductive logic programming, ILP. Train. Reducer identifies and ignores pointless rules, speeding up learning by 99% on some tasks while maintaining accuracy. Researchers at Tsinghua University and the Chinese Academy of Sciences developed WELA, a new method for predicting operator workload in nuclear power plants. Using fine-tuned LLMs, WELA dynamically estimates workload, outperforming existing models in accuracy, R² of 0.9012 in one scenario. This improves HRA data collection. Researchers at Stanford University studied how well large language models, LLMs, define climate terms. They compared LLM definitions to official IPCC glossaries. The LLMs scored an average adherence of only 0.57 to 0.59. This shows a gap between AI-generated and official climate definitions. Researchers at Université Paris-Dauphine (PSL) and École Polytechnique developed Co-Hi-RF, a new hierarchical clustering method. It uses random feature selection and repeated k-means, achieving up to 1000x speed improvements over other methods on large datasets. Researchers at Google DeepMind and the University of California, Los Angeles developed MagNets, a new image generation method. It uses smaller models initially, then larger ones for refinement, achieving competitive results with almost 3x less compute than previous methods. Researchers at Purdue University and the University of Cambridge developed RAP-GNN. It uses random diagonal weights in GNNs instead of learned ones. This reduces training time by up to 6x, and memory use by up to 3x, while keeping accuracy similar to fully trained models. Researchers at Aligned AI and UCL, along with a team from Oxford University, developed DATDP, a new AI safety method. It uses a separate LLM to check prompts for danger before times they reach the main model. This blocked 100% of successful jailbreaks from a previous study. Researchers at McGill University and the University of Tehran, along with colleagues from several other institutions, developed STAF, a new activation function for neural networks. Unlike previous methods, STAF uses a trainable Fourier series, letting the network adapt its frequency response. In one test, STAF achieved a PSNR of 104.57 decibels, far exceeding other methods. Researchers at the University of Oulu and MIT, along with colleagues from MBZUAI, developed a new sheaf-theoretic approach for federated multitask learning. This method handles complex client relationships and different model sizes, achieving similar accuracy to existing methods, but using up to 100x fewer bits for communication in some cases. Researchers at Peking University and Beihang University, along with a team from Tsinghua University and Meituan, developed FIRE, a new framework for improving large language model (LLM) training. FIRE combines multiple data quality ratings, boosting downstream task performance by 2.9% and cutting training FLOPs in half. Researchers at George Mason University and Carnegie Mellon University, along with colleagues from Otto von Guericke University, studied Gen AI use in 3 different workplaces. They found Gen AI use varies widely, with 78% of users bringing their own apps to work. The study also explores the knowledge needed to use Gen AI effectively in different roles. Researchers at KAIST and MIT created Mamba Glue, a new feature matching method. It uses a hybrid Mamba and transformer architecture. Unlike previous methods, Mamba Glue achieved 94.6% precision on the H-patches dataset, outperforming others. Researchers at Vrije Universiteit Amsterdam studied how 5 megaliters model export formats affect system integration. They used 30 units of analysis across 2 systems and 3 tech stacks. This research focuses on integration challenges, unlike previous work that mainly looked at performance. Researchers at the Indian Association for the Cultivation of Science and the Alan Turing Institute, along with other teams, created Pathogen, a generative AI model. It synthesizes gene expression data from cancer histopathology images. This improves cancer grading, 0.890 AUC, and survival risk, 0.861 C index, prediction, even without real gene data. Researchers at NVIDIA developed a new system to check if AI research code matches the paper's description. It uses LLMs and RAG to automate the process, improving accuracy and reducing manual effort. This helps ensure research reproducibility. Researchers at Sorbonne University studied how to understand complex AI systems with many agents. They used 6 new methods to analyze trained models without changing their design. This is different from older methods that focused on building simpler AI from the start. Researchers at MIT and Google Research developed Hassle-Free, a new framework for compressing large language models, LLMs. It directly minimizes a layer-wise reconstruction error, unlike previous methods. For the Llama 3 to 8B model, it reduced test perplexity by 12% on Wikitext 2 and improved zero-shot task performance by 15%. Researchers at Nanyang Technological University trained deep neural networks to predict the nonlinearity of Boolean functions. They achieved over 95% accuracy for 4 and 5 variable functions. This is a novel approach compared to traditional algorithms. Researchers at the University of Chicago and Yale used AI to analyze over 2,000 U.S. zoning documents. They found that form-based codes, FBCs, are widespread and linked to a 16% higher floor-to-area ratio and shorter commutes. This is new because previous studies used smaller data sets and qualitative methods. Researchers at EPFL present a new sampling method using stochastic interpolants and FBSDEs. Unlike other methods, this approach aims for exact samples in finite time by solving HJB-PDEs via machine learning. The method was tested on distributions with up to 10 dimensions. Researchers at EPFL studied generalization and memorization in diffusion models. They used random features neural networks and found a crossover point where the number of features equals the number of samples. This marks a shift from generalization to memorization. Researchers at VU Amsterdam and Peking University developed Connect, a new regularizer for pruning neural networks. Unlike other methods, Connect focuses on keeping the network connected. Tests on LLMA-7B showed a 9.13% performance improvement after pruning without fine-tuning. Researchers at MIT developed Asynco-MARL, a new approach to multi-agent reinforcement learning. It handles infrequent, asynchronous communication between robots, using graph transformers to learn communication protocols. The result? Similar performance to other methods, but with 26% fewer messages exchanged. Researchers at the University of Cambridge created heterogeneous image graphs, HIGs, for image synthesis. HIGs represent images and conditions as interconnected graphs, unlike previous methods. This improved FID scores on visual genome from 15.63 to 8.79 at 512 by 512 resolution. Researchers at Carnegie Mellon University and the University of California, Berkeley, along with other institutions, studied how large language models, LLMs, can detect fake news. Their synthesis reveals that while LLMs improve accuracy, e.g., MilkFD reached 95.2% accuracy on fake newsnet, challenges remain in real-time detection and cross-platform consistency.
That's the end of today's paper highlights. Great job you made it this far. Now go conquer your